Next part of your module is retarded potential. So we have seen what is electric scalar potential, what is your vector magnetic potential, what is the relationship between your electric scalar potential and electric field intensity, and how exactly it make a replica in your magnetic scalar potential and magnetic vector potential. Same way here, the retarded potential is also one of your important topic. Why? Because it focuses mainly on the modified form of Amperes law. So we know that the modified form of Amperes law, that is time varying field Maxwell's equation, is curl H is equal to J plus dou D divided by dou T. J is nothing but conduction current density. Dou D by dou T is nothing but your displacement current density. So you replace H, that is magnetic field intensity, in terms of magnetic flux density. So you will get curl of B by mu, because we know that B is equal to mu into H. In the place of H, B divided by mu you have to substitute. We know that D is equal to epsilon into E. In the place of D you substitute it with epsilon into E. After substituting you will get curl of curl A, because already we have substituted to prove it is not contradictory with the already proven laws. B can be curl A. So curl of curl A is equal to J plus epsilon into dou E divided by dou T. Curl of curl A, you need to apply a vector identity for this side. So when you apply a vector identity, you will get divergence of divergence A plus minus divergence square A, which is equal to mu J plus mu epsilon into dou D divided by dou T. And what is the relationship between your electric scalar potential and electric field intensity? We know that E is equal to minus divergence dot V, because it satisfies. If you put only E is equal to minus divergence dot V, it satisfies only for your steady magnetic field. Suppose if it wants to satisfy for your time varying field, the relationship between your electric scalar potential and the electric field intensity is E is equal to minus divergence V minus dou A divided by dou T, to satisfy your time varying field. Substituting one over the other, you will get mu J plus mu epsilon divergence dou V divided by dou T minus mu epsilon dou square A divided by dou T square. So comparing both the equations, you will have E is equal to minus divergence dot V minus dou A divided by dou T. In case of steady state field, your electric field intensity is equal to the negative gradient of your electric scalar potential, whereas in case of your magnetostatics, if you consider both your electrostatics and magnetostatics present in a concern, then your E is equal to minus divergence dot V minus dou A divided by dou T. It is your modified form for the modified form of Amperes law. It is your modified form of Amperes law, and it satisfies your time varying field. Taking divergence on both the sides, you are going to get divergence square V plus dou divergence dot A divided by dou T is equal to minus rho V divided by epsilon. It looks like your Laplace equation. Laplace equation in case of electrostatics is divergence square V is equal to minus rho V divided by epsilon. If it wants to satisfy your time varying field, then the Poisson's equation in case of your time varying field is divergence square V plus dou divergence A divided by dou T is equal to minus rho V divided by epsilon. So after solving, we will get divergence square A minus mu A dou square A by dou T square is equal to minus mu into J. So this extraction is from your vector magnetic potential derivation. After that, you will get the weak term called A is equal to integral over the volume of space mu J vector into dV divided by 4 pi R. So it represents your vector magnetic potential, and this is your retarded vector magnetic potential, which satisfies your time varying field analysis. Next, wave propagation equation. What is meant by wave? First, before getting into the topic, we should know what is meant by wave. Wave is nothing but it is a physical phenomena which appears at one point with certain amplitude, and it reflects at some other point with some other amplitude. This is called as your waves. So wave is defined as it is a physical phenomena that occurs at one place in a given time and is reproduced at the other place in later time delay, which depends on the space separation between the 2 points considered. So wave means it is having both magnitude as well as your phase angle. So magnitude and phase angle, it is a very important factor when you want to analyze the wave propagation equation. To analyze Analysis of wave propagation equation. The following Maxwell's equation is utilized. This Maxwell's equation under time varying field has to be utilized for the analysis of wave propagation equation. Why we want to utilize the Maxwell's equation for time varying field means wave is nothing but it is a physical phenomena that occurs at one point in a given period of time and is reproduced at other place. Here the time is getting changed, so we need to have a time varying analysis. For that case, we are going to utilize divergence dot d is equal to 0, curl E is equal to minus dou b by dou t, divergence dot b is equal to 0, curl H is equal to j plus dou d divided by dou t. All these equations are Maxwell's equation for your time varying field analysis. Before we will go into the exact derivation, we need to have certain assumptions. In free space, your conductivity, permittivity and permeability all are 0. And we need to perfect lossless dielectric medium we have to consider. And lossy dielectric medium means your conductivity will not be equal to 0. Now we will solve. The medium is isotropic, like that we have to assume. So medium should be isotropic and homogeneous, and you have to assume a free space for the analysis of wave propagation equation. The first derivation is wave propagation equation in terms of E or D. For this we need to consider the Maxwell's equation. Faraday's law you have to consider. So when you consider the Faraday's law in a time varying field, curl E is equal to minus dou b divided by dou t. B in terms of H, if you write, you will get mu into H. And H is equal, so if you are taking curl on both sides. First you have to write your Faraday's law equation. Then taking curl on both sides, you will get curl of curl E is equal to minus mu into the curl of dou H divided by dou t. So after solving, you will get a equation divergence square E is equal to minus mu dou E divided by dou t minus mu into epsilon dou square E divided by dou t square. So in general, I will get divergence square E is equal to mu sigma dou E by dou t plus mu epsilon dou square E divided by dou t square. This is your wave propagation equation in terms of your electric field intensity in terms of E. It is your wave propagation equation in terms of E. If you see your right hand side as well as your left hand side, both the sides, all the terms called E only it is coming. So your first parameter is first order differential equation of your electric field intensity. Second parameter, second order differential equation. The constant in the first term is mu into epsilon and the constant in the second term is constant in the first term is mu into sigma and the constant in the second term is mu into epsilon. So you can remember, suppose if you want to write the wave propagation equation in terms of B in terms of D, that is electric flux density, you will get divergence square D is equal to mu sigma dou D by dou T plus mu epsilon dou square E divided by dou T square. So only difference is E is replaced with D. The above two equations are called as wave propagation equation in terms of E or D. So when you put for a free space, in case of free space, your conductivity is equal to 0, epsilon is equal to 0 and mu is equal to 0. When you substitute all equal to 0, you will get divergence square E is equal to mu naught epsilon naught dou square E divided by dou T square. Because in case of free space, conductivity, if you put conductivity equal to 0, mu equal to mu naught and epsilon is equal to epsilon naught, you will get divergence square E is equal to mu naught epsilon naught dou square E divided by dou T square. For a perfect dielectric, conductivity will be equal to 0, whereas mu and mu naught is equal to mu naught into mu r, epsilon naught into epsilon r. Substituting, you will get, it is your wave propagation equation for a perfect dielectric medium. Wave propagation equation in terms of H or B. So to solve the wave propagation equation in terms of D or E, first you have to consider your Faraday's law, taking curl on both sides. First step is you need to assume your Maxwell's equation, then taking curl on both sides, apply vector identity, expand your formula and just you identify the value of E wave propagation equation in terms of E and D. First order, second order. The constant in the first order is mu sigma, so constant in second order is mu epsilon.